Hello everyone, welcome to the first Integrated 1 lesson featured here on this channel. Today we'll be covering writing equations in slope-intercept form. So let's start with identifying what the slope-intercept form looks like. It looks like this. Y is equal to mx plus b. Now let's identify the different components of y equals mx plus b. M is the slope. B is the y-intercept. X and y, those are different. X, I like to call that the input value, or the value that you put into the equation. Y, I like to call the output value, which is what you get, the output that you get after putting the x value in. At times, you are given the task of writing an equation given the slope and a point that the line passes through. So, the prompt will look something like this. It'll give you, for example, we'll call this example 1. It'll say, okay, your point is -1 and 4. And your slope is equal to -1. And it'll say, write an equation. EQU for short. So this is the point. A line passes through this point and has a slope of -1. Well, let's first identify what this point is. This is an xy pair. And, well, this is the slope. Okay, cool. So, let's start using the slope-intercept form equation. Y is equal to mx plus b. Now, we identified that m is the slope, x is the input, y is the output, and b is the y-intercept. Well, in order to write the equation, we need all of these. But I noticed that we only have an output, an input, a slope, but we're missing the y-intercept. You can't write an equation of a line without a y-intercept. So we have to solve for it. Let us begin with just plugging numbers in. You know, the 4 in the pair is the y, so 4. We know that the slope, or m, is -1, and that's being multiplied by the input value, or x, which is also -1, plus b. Now, if we want to solve for b, or if we want to figure out what the y-intercept is, we have to get b by itself. So, 4 is equal to -1 times -1 is +1, plus b. To get b by itself, we just subtract 1 to both sides, and you're left with b is equal to 3. Cool. Now we have our y-intercept. Now that we have our y-intercept, we can write the equation of our line. So we'll say y is equal to mx plus b. So now we'll plug in the values that matter, which is the slope, -1 times x plus 3. Great. Now we have our equation, and we could find any point using this equation. For example, just to test it, this could be our check. We'll say that y is equal to -1, and let's say we wanted to check what our value would be at x is equal to -1. So we plug in -1 here, plus 3, and our y value turns out to be, well, -1 times -1 is just 1, so y is equal to 1 plus 3, so y is equal to 4, which, according to our pair, is correct. So everything checks out. We'll work on another example using the same method. Example 2. This time our point is 1, 0. And our slope is +1. go ahead and pause the video here, try to solve this on your own, and go ahead and unpause it when you think you got it. Great, hopefully you paused the video and you solved it on your own. So, we'll identify that this is an xy pair, the slope is 1, and they still want us to write an equation. So again, we'll use the function, or the equation, sorry, y is equal to mx plus b. And again, we have an input, an output, a slope, but we're missing the y-intercept. So we'll have to solve for that again. We have a y value of 0. Our slope is 1 being multiplied by 1 plus b. So to get b by itself, we just subtract 1 to the other side. B. So b is equal to -1. Awesome. Now, we'll just rewrite the equation again over here. Y equals mx plus b. And now we have the values that matter. We have the slope, which is 1. And we have x. And because b is negative, we'll write -1. We can again do the check method, where we say, well, y is equal to 1, and we'll use this value over here, this value of x. And if everything checks out, when we plug in 1 here, we should get 0. So y is indeed equal to 0, proving this point and this equation, more importantly, correct. In other instances, you're given pairs of numbers. So, for example, you'll be given, we'll call this example 1, the pair 9, -2, and 4, 3, my apologies. And it says, write an equation. Write an equation knowing that that the line passes through both of these points. Well, let's start off with writing the slope-intercept form equation. Y is equal to mx plus b. Okay, cool. Well, let's see what values we have. Okay, well, we have y's, we have x's, but this time we're missing the slope and the y-intercept. So we have a problem. There is an equation, however, to solve for him whenever you're given two pairs. And it is your job to familiarize yourself with it. It is that y2, the slope is equal to y2 minus y1 over x2 minus x1. Now you're thinking, well, which ones are x2 and which ones are x1s and y2s and y1s? Subscripts. Confusing. Well, we already concluded that these are xy pairs, yes? Good. Now you can decide which one is your x1 and which one is your y1 and which one is your x2 and y2. So we'll call this x1, this will be y1, and this will be x2, and this will be y2. After this, it's just a matter of plugging things in. So that's your first step. M is going to be equal to, well, y2 minus y1, which is -2. You have to always take the negatives into account. Over x2, so 4, minus x1, which is 9. This will be rewritten as 3 plus 2 over 4 minus 9, which is equal to positive 5 over -5, which is -1. Awesome. Now you have your slope. So, m is equal to -1. Very important. Now, your second step. Well, let's just do a little quick check. Y is equal to mx plus b. What are we missing now? Well, we still have the pairs, right? We have the output, the input, and now we have our slope. Now all we need is b. And this is where everything gets familiar again. All I have to do is solve for b. But the common question is, well, which one of these points or pairs do I use and plug into here? Well, that's up to you ultimately. They both result the same. So, I like using smaller numbers, so I'll use this pair. So we'll plug in 3 is equal to, the slope is -1, the x is 4, and we'll use b. Now remember, if you're using this y, you must use this x. And if you're using this y, you must use this x. You must use the pairs. You cannot use this 3 and then this 9, or this 4 and this -2. They have to be within the same pair. Great. So let's continue getting b by itself. This will be -4 plus b. So you add 4 to both sides. So b is equal to 7. And you're just about done with this. After this, it's just step 3, which is plugging all the important values in. So you have y is equal to m, which is -1, x, plus your b value, which is 7. So this is your function, or your equation. Now, other times, your job of writing equations come off as word problems. So this word problem, we'll call it example 1 for the word problem. Word problem. This can be found on page 229 of the Integrated Math 1 textbook. After all, this is tailored towards Integrated 1 Math students. So the word problem goes like this. Greg is driving a remote control car at a constant speed. He starts the timer when the car is 5 feet away. After 2 seconds, the car is 35 feet away. Okay. Well, the first step I like to take is drawing it. I'm more of a visual learner, so when I get to see it in front of me, it becomes easier. So he states. So Greg, we'll make him a star. Greg is 5 feet away from the car. Let's just draw the car here. So a circle will be the car. Right? He starts the timer when the car is 5 feet away. So I'll make this distance 5 feet. Cool. And we could write this in words now. When time is equal to 0 seconds, the car is 5 feet away. Awesome. Then it states, after 2 seconds, the car is 35 feet away. Okay? So, and this will not be drawn to scale, obviously. So now, this distance has grown to 35 feet. Oh God. Just cannot write today. 35 feet. We could write this in words as well. When t is equal to 2 seconds, when the time is equal to 2 seconds, the car is 35 feet away. Awesome. Sorry. There we go. So, when we look at this, okay, well, we have t is equal to 0, and we'll call the distance. I mean, we could always just say d is equal to 5, and d is equal to 35, just for the sake of using only one letter. Well, this, to me, kind of looks like pairs. Well, how? Well, we can treat time as the determining variable, or x. So we could say, well, time is equivalent to x, and distance is the same thing as y. Well, why is that? Well, because the distance is changing because of time. Time is not changing because of distance. So as time continues, the distance, because it states that the remote control car is changing at a constant speed. So that means that distance is changing because of time. So we can identify using a little table. Time, or x, and then the distance, or y. Cool. So we identify that at 0 seconds it is 5 feet, and at 2 seconds it is 35 feet. Well, this can be rewritten as pairs 0, 5 and 2, 35. X and y values once again. Okay, cool. So let's get to solving the actual problem. It says write a linear equation to find the distance d of the car from Greg. Okay. So I like to focus on the first part of this. It says write a linear equation. Well, where else have we seen writing a linear equation using only 2 points? That's exactly right. In the previous example. So, in the previous example, it goes, we're giving x1 and y1, x2 and y2. Awesome. So we know that we're missing the slope and the y-intercept. So our first step from that one was to use the formula m is equal to y2 minus y1 over x2 minus x1. So this is going to be 35 minus 5 over 2 minus 0 is equal to 30 over 2, which is equal to 15. Cool. Now we have our m. m is equal to 15. Second step is to identify the fact that we're only missing b now. That's all we're missing. So, now we have our 2 pairs and our slope. Well, now this looks even more familiar. This is the even more previous example. So, let's go again by drawing our y is equal to mx plus b. And we can decide which pair to use. I'm going to use this one because I see that it has a 0, and zeros are my best friend. I'm very lonely. So we're going to plug in the y. 5 is equal to m, which is 15, as we determined, and the x is 0 plus b. Well, 15 times 0 is 0, so we're left with 5 is equal to b. Great. Now, step 3, it's just a matter of plugging everything in. Y is equal to mx plus b. I don't know how much of that you've actually seen. Which turns into y is equal to 15x plus 5.